Well, good evening, everyone, and welcome to the kickoff for a virtual Cosmic Carnival that is happening on the Museum of Natural History and Science's YouTube channel, and it's being hosted by the Albuquerque Astronomical Society. So those of you who live here in Albuquerque know that every year the Albuquerque Astronomical Society does the Cosmic Carnival at the Rio Grande Open Space Nature Center, but of course we can't do any in-person programs this year. So to make up for that, this year we're doing a virtual Cosmic Carnival. It's actually going to be available for an entire week. And here in just a moment, I believe in the chat, you will see the link to get to the online Cosmic Carnival. And in addition to this kickoff event that you're watching right now, there are actually several videos that you can watch, which basically demonstrate the different activities that you would have seen at the Cosmic Carnival if we'd been able to do it on the one Saturday that we normally do it. So it's an online event, but we have hopefully included nearly everything that you can do if you'd come to the Open Space Visitor Center. And in fact, you can still go to the Open Space Visitor Center and get some star maps. So there's one activity on there that shows you how to build a star map. They actually have the star map raw materials basically there at the Open Space Visitor Center. If you want to stop by there, they'll give you a printout of that and they'll help you put one together. So that'll be happening all this week. So sorry that we can't let you look through telescopes in person this year, but hopefully this will somewhat make up for it. In just a few minutes, we'll start giving you a tour of the night sky and show you some pictures of some other objects that you can see out in space. And I'll be joined by another member of the Astronomy Club that'll help out in just a moment. But we actually have Jeff Skelton helping us out on the YouTube channel. And Jeff is going to be answering any questions that you want to put in the chat. So we're not going to stop and ask for a specific time for questions. We're just going to leave the chat open during this entire video. So if you have any questions at all during the entire video, just go ahead and type them in the chat over there, and Jeff will be happy to answer those for you. The software that I'm going to be using tonight is called Stellarium. And it is actually software that you can download on your computer at home and use anytime you want to. And hopefully in just a few moments, Jeff will be putting the links to both the Cosmic Carnival web page and also the link to actually visit Stellarium. And you can download the software. There's actually an online version of Stellarium, but it's very limited, and you can actually there's a lot more features that you can use if you actually use download and install the version on your computer. So I'm going to go ahead and switch over to Stellarium now. And we are actually looking at the sky the way it would appear right now. And I accidentally clicked on something there. So you can see the sun is setting over here in the west. Jupiter, Saturn, Mars, and Altair, a star, are all labeled on Stellarium. And I'm going to start off talking about the planets you can see in the sky tonight, and show you some of the features of Stellarium as we go along. So the first thing I'm going to do is choose Jupiter on here. And one of the features of Stellarium is if you choose an object, it gives you all kinds of information about that particular object over here. So you can read down and see where its position in the sky is. You can see how long it takes light that's reflected from the sun off of the planet to get back to the Earth, and you can see how far away from the Earth it is, and all kinds of cool information over there on the side of the screen. But another interesting thing you can do is after you've selected an object, you can actually zoom in on it. So we've zoomed in on Jupiter a little bit. I think we can zoom in just a little bit more. And you see some other things that have been identified next to Jupiter. Those are actually 3 of the 4 largest moons of Jupiter. Ganymede, Europa, Callisto, and Io is probably behind or in front of the planet tonight. So even if you have a pair of binoculars, if you have a telescope, that's better. But even if you have a pair of binoculars, you can point those at Jupiter. You may not be able to see the cloud bands on it, those are the stripes made by the different colored clouds on Jupiter. And in here you see them on color, but if you look at them through a telescope, your eye is actually not sensitive enough to be able to see the colors on Jupiter. But you can definitely see the different. They'll look like different shades of gray. They'll look like stripes that are different shades of gray. And then next to it, the moons probably won't look quite like these dots here. They'll just look like little pinpoints of light. So they'll basically look like stars that are not twinkling right next to Jupiter. But you'll know that they're the moons because they're actually going to be lined up with those cloud bands. Okay. And sometimes they're all on one side of the planet like they are tonight. Sometimes there's some on one side, sometimes there's some on the other. But that's what you're looking at when you look at Jupiter and see those little dots next to it. All right, let's zoom back out all the way. And I bet y'all would like to go look at Saturn. So let's lock in on Saturn. You can read some of the information about it over here on the side. It's an awful lot of information that you can. I've actually got some of the information turned off. So there's actually more information about objects in the sky that you can find out from Stellarium. Zoom in on Saturn. And even through a pair of binoculars, you don't have to have a telescope, through a pretty decent pair of binoculars, you can see the rings around Saturn. And let's zoom in a little bit more, and you can see some of its moons. If you can't see anything else, you can probably at least see the largest moon of Saturn. And that's Titan right over here. Okay, I'm going to zoom back out and lock back in on Saturn again. The lock failed and I got to zoom back in, or else it will keep drifting out there. There we go. All right, so Titan is going to look like a bright point of light next to Saturn. And if you have a pretty decent sized telescope, you probably will see some of the other moons of Saturn too. You might see Dione, Tethys, Enceladus. Mimas is pretty hard to see. Hyperion's pretty hard to see too. So those, and Rhea is one of the bigger and brighter ones. So those are some of the moons of Saturn that you might see. Now, I thought we could do something a little bit fun with the chat. I meant to do this when we were at Jupiter and I forgot, so I'm going to do it now that we're at Saturn. I want everybody to type into the chat how many moons they think Saturn has. So you can see a few of them on the screen, but this is not nearly all of the moons that Saturn has in total. So I want you to type into the chat how many total moons you think Saturn has. And we'll give you the correct answer here in just a moment. I'm going to go ahead and zoom back out while we're waiting for you all to type in some guesses. And I'm going to go over here and let's look at Mars while you all are thinking about how many moons there are. Now, don't cheat and look it up on the internet, but just make a guess about how many moons. In fact, if you look it up on the internet, you might not even get the right answer because the number have changed pretty recently. But while you're thinking of a guess of how many moons there are around Saturn, let's zoom in on Mars and talk about that. And then we'll go back to Saturn and see if anybody got the right number. All right. Mars is easy. You only have 2 moons around Mars, Phobos and Deimos. Fear and Dread are the names, if you translate the names of those moons into English, that's what they stand for. And that's because Mars was the god of war. And he's that fiery red color. It comes from all the rust on the surface of Mars. And if you look at Mars was what was called opposition recently, which means that it was on the opposite side of the Earth from the sun. And when it's in that position, it's also the closest to the Earth. And in fact, the orbits of Mars and the Earth are not perfect circles. They're slightly elliptical. And so Mars was a little bit closer to the Earth during this opposition than it normally is. It'll be, let's see, I believe the year 2039 before Mars is as close to the Earth again. Of course, every couple of years Mars will be in opposition, but it just won't be quite as close again until 2039, but it'll be reasonably close. So now is a really good time if you do have a pair of binoculars or a telescope to go out and look at Mars, because it'll appear a little bit bigger. You'll be able to see some more of these details. You see that it does have some detail on it with these light and these dark areas on the planet. All right. So let's talk for just a second about how to tell the difference between planets and stars. It's not very noticeable on this on Stellarium, but in the real night sky, it's going to be a whole lot easier to see that the stars twinkle, but planets don't. Also, planets move very slowly among the stars, and they also move along a particular line in the sky. Whoops, which is not that line. It's that line. This is called the ecliptic, and that's the path that the sun and the moon and all the planets move along in the night sky. So if you see a bright point of light that's not twinkling, and you plot it over a position of several, or you plot its position relative to the stars over several weeks or months, you'll notice that it's moving, then it's definitely a planet. I was kind of rushing through that because I wondered if anybody noticed this thing right here and wondered what that thing moving through the sky was. That is a satellite. So another cool feature of Stellarium is that it will actually show you the current positions of satellites in the night sky, so that, and they also look like not twinkling points of light that are really obviously moving. Of course, obviously, you can't see, even though the planets are moving through space, they are so far away, you can't detect their motion in the sky just over one night. But you can definitely see satellites moving along. So if you see a point of light that's moving at about that speed among the stars, that's going to be a satellite. If it flashes, especially if it flashes different colors, then it's not a satellite, but it's an airplane. You can only see satellites for a certain duration of time after the sun goes down in the evening and before it comes up in the morning, because most satellites aren't making their own. I think the International Space Station is the only satellite that makes its own light. The rest of them are just reflecting light from the sun off of their solar panels. You can also see that the planet Uranus is up in the sky right now, but it is so far away that you definitely have to have a telescope to see it. You won't see it as a point of light in the sky. We'll zoom in on it really fast. And if you got a really pretty good sized telescope, you might just be able to resolve the planet as a little blue ball, and you probably won't be able to see any of the moons near. You might be able to see some of the moons near it, but normally you need a professional telescope to see that see those moons that are that far away and that small. All right, let me look back over here and see if anybody guessed the number of moons. So 3 people, one of which I know is in the Albuquerque Astronomical Society, guessed 72. So it kind of depends on what you consider a moon to be. 72 or 73 is what I think NASA might actually say 73, but I'm not 100% sure about that. I'd have to check again. But anyway, those we'll take those as correct guesses. So very good, you 3 people that guessed that. They had, the number of moons around both Jupiter and Saturn have increased over the last few years, and they because they have better telescopes that are able to find smaller things in space, and so they keep finding these new moons around planets. I did ask how many moons there were around Saturn, didn't I? I just realized that's actually not the correct answer. The correct answer for the number of moons around Saturn is actually 83, because they found some new moons. Yep, Jeff just typed that in there. So there are some unofficial moon-like objects, like he says, that they haven't officially designated as moons yet. But there's actually, I believe we're up to 83 of those. So Jeff will have to check into that for us. I believe we're up to, 79 moons around Jupiter, if I'm not mistaken. So, like I said, Jeff can double check on that for us. So they found several new moons around Jupiter and around Saturn pretty recently. So I think the current number that we know about, or at least the current number of moons that we are suspecting are around the gas giant planets, is Jupiter 70. I think it was 78 or 79 in Jupiter, and Saturn rather around 82 or 83. Okay, Jeff, is that right? Check that out and type that in the chat for us. Let me know if that's right. There's definitely 2 moons around Mars. All right. So let's get on to some other things that you can see in the sky. We have some deep sky objects up in the sky tonight that we want to talk about as well. And one of the other things that we can do with Stellarium is that we can turn on some pretty pictures that show you some artwork from all the constellations up in the night sky. And I can zoom out just a little bit so you can see them. So these constellation pictures were made up by the ancient Greeks and Romans thousands of years ago, and astronomers still use those to actually divide up the night sky, and that helps people figure out where things are, where they exist in the night sky. When astronomers are trying to figure out or trying to tell another astronomer where to look for something in the sky, like the planet Mars, basically they would say that Mars is in the constellation of Pisces. So it's just a convenience. It's a way of describing to other people where to look for things in the sky. So the sky is divided up into constellations, kind of the same way the United States is divided up into states, or the state of Mexico is divided up into counties. And we can actually turn on the names of those different constellations too. There's a special, I'm going to turn the ecliptic back on because, you don't see a yellow line in the real sky. If you do, it's I'm a little worried about you. But you can see that the ecliptic moves through 12 of those constellations: Sagittarius, Capricornus, Aquarius, Pisces, Aries, and Taurus is coming up over there. And those are the zodiacal constellations. So those are the constellations. Those are the 12 constellations you can see the sun and the moon and the planets in. Okay. All right, we're going to take a look at a couple. There's 88 constellations in the sky in all. We don't have time to point out all of those, but we'll point out a few of them that are important to these deep sky objects that we're going to look for. And if you find the planets Jupiter and Saturn in the sky tonight, just to the right of that, you might be able to see the Milky Way. If you are way far out in the country here in New Mexico and lots of places, you can see the Milky Way stretching across the sky. And if you go up from where Jupiter and Saturn are in the south and you travel up the Milky Way, you're going to find 3 bright stars. And if we zoom in a little bit, they're all identified for us here. We're going to see Deneb, Vega, and Altair. And I can't draw this in. Well, I can draw this in for you. I just realized I turned that on. Here we go. So a couple of other things mixed in with it, but you can see the triangle right there. So this is called the summer triangle. Of course, it's not summertime outside anymore, but you can still see the summer triangle through most of the fall too, and even the first little bit of the winter. And so that's made up of those 3 stars. And those 3 stars actually mark the positions of 3 different constellations. So there's 2 different kinds of star pictures up in the night sky. There's constellations that I was talking about just a little bit ago. There's 88 of those. And then there are also asterisms, which are more modern star pictures, and they're usually a little easier to find. In fact, here is the Big Dipper. It's kind of hidden behind that tree, and here is the Little Dipper, and those are actually asterisms too. They're actually asterisms within the constellations of Ursa Major and Ursa Minor, the Big and Little Bears. Okay. But anyway, let's go back to the triangle, and we'll turn on shouldn't have turned off the constellations. We'll turn it back on. You can see the 3 different constellations that are made up that belong to those 3 stars. You can see in Vega, we have Lyra the Harp. In Deneb, we have Cygnus the Swan. And in Altair, we have Aquila the Eagle. Okay, so 2 birds and a harp. And if I turn them off and you're having a little hard time finding them, I can give you a little bit of help. I can show you that there's a little square. There's a satellite right there. But I can see what satellite that is. Okay, so it's a communication satellite. But there's a little square right there that kind of makes the main part of the harp. And then one side of that, the handle on the top is marked by Vega. Altair and the 2 stars on either side of it and these 2 stars below it kind of make the head of Aquila, and the body goes down kind of through the Milky Way, the wings stretching out over there. And then Deneb marks the tail of Cygnus the Swan. So if you go from there down through that star, and this one, which we're going to talk about again later, you kind of get the tail, the body, the neck, and the head of the swan. And then going out this way, you get 1 wing. And going out this way, you get another wing. And the asterism, you may have noticed, within that is also a giant letter T or a cross. So that same group of stars, Cygnus of Swan, the asterism within Cygnus of Swan is also called the Northern Cross. Okay. And you can see the Milky Way goes right through the middle of the triangle, and the Swan is flying right down the middle of the Milky Way there. Okay. All right. So we're going to zoom. We're going to start talking about some deep sky objects, and I'm going to bring in one of the members of the Albuquerque Astronomical Society. He just finished his term as president of the Albuquerque Astronomical Society. This is Jim Fordyce. He is still on a committee that's planning a celebration that's happening. It was supposed to happen this year, but it's going to happen next year. The Albuquerque Astronomical Society is actually going to be hosting the annual meeting of the Astronomical League, which is the national organization of all amateur astronomers. And it's going to be meeting next year in August here in Albuquerque. So this is a big deal. And Jim Fordyce down there is in charge of the committee that's pulling that meeting together. So I'm going to go ahead and switch over to Jim now, and he's going to talk about an object in the summer triangle. And actually, I'm going to show you where that object is, and then we'll turn it over to Jim. Let me switch back to... Sorry, I think we lost the audio there for just a second. A lot of these objects start with the letter M, and that means that they're a Messier object. And so a Messier object are ones that were cataloged by Charles Messier. He was an astronomer that lived a long time ago. He was actually looking for comets, and he actually found a bunch of other objects that weren't comets. But in the process of doing that, he made a catalog of all the objects that were not comets, and we still use that today. So there's 110 Messier objects. This first one is called M57. I looked for it earlier, so it's already in my search list there. And we can zoom in on it, and you can see where it is in the sky. And right now I'm going to switch back over to Jim, and he's going to tell us what this object is. And I think he's got another picture of it too.
So can you hear me? Can you hear me good,
yes.
Jim?
Yes.
Okay, so this is Jim Fordyce. I'm sitting in my driveway on Rio Grande Boulevard. I had hoped to be able to take pictures tonight and show you the pictures, but we had some technical issues, and the wind's kind of busy tonight anyway, so we might not have gotten any good pictures anyway. But we're just going to give you some can shots tonight of these objects and tell you a little bit about them. First off, again, my name is Jim Fordyce. I am actually the task president of the Albuquerque Astronomical Society, and I'll be around for a while yet as president. I will be happy to talk to you anytime about our society. We have a website at task.aas.org. You can learn more about us. Do we have the ring nebula up there, Jim, for everybody to see?
Yes.
Okay, so as Jim said, the first object tonight is Messier 57. It's called the ring nebula. It's one of the more popular items that you can see in the sky. It takes a telescope really to get a good view of it. It's not terribly large, but it's actually quite interesting. It's what's called a planetary nebula. So when astronomers first started looking at these objects back in the 1700s or so, what they saw was something that looked like, well, maybe that's a cloud forming into something that's eventually going to be planets. So they thought, hey, that's great. That's the beginning of a new solar system. Well, instead, what we found out in more recent times, in fact, this is the end of a solar system. This is the end of a star's life, at least the main part of its life, its life on the main sequence. Our sun is a standard yellow dwarf star, a medium-sized star. It will do the same thing that this ring nebula is doing in about 5 billion years. Our sun will live about 10 billion years, and at that point, it will have exhausted all of the hydrogen in its core, and it will start fusing helium. When it does that, it gets hotter and it blows up and it becomes what's called a red giant. And after it goes through that phase and it burns up all of the helium also in the core, and it runs out of both helium and hydrogen in the core, it will basically shut down and it'll blow off most of its mass, and it will become what's called a white dwarf. But when it blows off all of that mass from the sun, what it does is that material moves out into the galaxy. And this is what you're seeing with the Ring Nebula right now. This is a star that now is a white dwarf at the center, and you can see that small dot at the center. That's the white dwarf, and around it, being illuminated by that white dwarf, is the material that was blown off from that star. Now that material is moving out into the galaxy, and eventually, maybe in a few billion years, it'll be collected together, and it will form into new stars and new planets. And that's how we all come from star stuff, as Carl Sagan said back a few years ago, is that all of the elements that make up us and the Earth and everything around us, except for helium and hydrogen and a little bit of lithium, which all came from the Big Bang, everything else came from stars. And stars like our sun can produce elements up to iron. It takes other events to create elements higher in the periodic table than that. And so that's what you're seeing here from the Ring Nebula, is all of this stuff from iron on down to hydrogen going off into the galaxy and being dispersed back. So hopefully in a few billion years, as I said, it'll become part of a new system, new stars, new planets, and whatever. And so that is something that in about 5 billion years or so, you'll see our solar system doing. So if you live that long, you might actually get a chance to see it. There's some other reasons why you won't actually make it that far, but we don't need to go into all the details right now. I see Jim talking, but I can't hear you, Jim. Do you hear me? Okay. So is there anything else you want to talk about on the Ring Nebula? Okie doke. Okie doke. So this is M56 message. 6. It's what's called a globular cluster. It is a collection, about pretty much a spherical collection of stars. In this case, this guy is at about 32,900 light years from us, and it's made up of several 100,000 stars. It is one of about 130 globular clusters around the Milky Way galaxy. These globular clusters are very old. They're all in the range of about 11, 12, 13 billion years old. So about the same age as our galaxy. And these are thought to be original collections of stars that grouped together and could have formed the center of a galaxy, but and in some cases actually probably were the center of small galaxies that have now been subsumed by the Milky Way itself, but the core has remained. For instance, a globular cluster called Omega Centauri is thought to have been the core of a dwarf galaxy at one point, and now it's just got the core itself, and it's called a globular cluster. So these are very interesting objects. If you think about the density of these stars in the center of these objects, if you were actually on a planet in the middle of one of these things, it'd be pretty bright at night because there'd just be stars all over the place. Instead of having the closest stars to the sun as far away as 4 light years, you'd have many stars in the range of 4 light years if you were at or near the center of one of these globular clusters. It would just be absolutely amazing. On the other hand, though, if you were in the center of one of these globular clusters, you probably wouldn't be able to see much of the rest of the galaxy. So all you'd know about is just what's around you. You wouldn't have much idea of the rest of the galaxy and the rest of the universe because it's just so bright you couldn't see everything. So we're kind of lucky in that we're all off by ourselves, and it's kind of the outskirts of the Milky Way galaxy, so that we can look at all these things and get a better understanding of what's around us. But globular clusters are just great to look at. They're very interesting objects to look at through a telescope. One of the other important historical facts about globular clusters is that they helped astronomers in the 1920s and 30s determine that we are not near the center of the galaxy. What happened was they started plotting where these globular clusters are, and they determined that they're all orbiting around a point about 23,000 light years away from us. And they determined that that's where the center of the Milky Way galaxy is that point that all of these globular clusters are orbiting around. And so they realize is that the Earth is not at all close to the center of the Milky Way galaxy. So that was a very enlightening thing that came about simply by determining the distance to these globular clusters and where they're scattered, and making some good determinations using the science of the matter to figure out what it tells us. And that's what it told them. And all very accurate at this point with a lot more knowledge now. So globular clusters, as I said, about 130 of them. All large galaxies have globular clusters. We can see lots of them around the Andromeda galaxy, for instance, and other galaxies. So they're very well-known and fairly common objects.
All right, and I apologize because I understand that you couldn't hear me during the last segment because in order to try to get rid of that echo that some people were hearing, I muted myself. So you couldn't hear me when I went back to Stellarium, which is what I'm. So we're going to hop on to the next object. So you saw what I was doing with Stellarium. There I was just taking us over to that globular cluster, which was very close to the Ring Nebula that we looked at just a little bit ago, but let's zoom out from that. And we're again not, so the Ring Nebula is right in there. There's somewhere in there is where the globular cluster is. And then we're going to go to that star, which is right near all those. And I mentioned when I was showing out the constellation when I was showing the constellation of Cygnus just a little bit ago, I said that we were going to be zooming into or talking a little bit more about that star. It's called Albireo. I was a little off from it. And let's zoom in on it. So if you zoom in on it enough, you can actually tell that it is not just one star, but it's actually two stars. It's a bright blue star and a bright yellow star. And let's see, Jim, do we have a picture, a close-up picture of Albireo?
Yeah, I'm bringing it up right now. Second. You should have it now. You should have it now. Got it?
I do. Yes, we can see it now.
So Albireo is a multiple star system. It has two stars in its system, otherwise known as a binary system. And an interesting fact about stars is that most stars are in multiple star systems. So the fact that our sun is off by itself is actually kind of a minority case. If you look at all the stars that are in our galaxy, most of them are grouped with other stars. In some cases, as many as 6 or 7 or more will all be gravitationally bound and moving through space together. So in this case, though, we have 2. The reason why Albireo is so interesting is because it has such great colors. The Albireo is also called Beta Cygni, and Beta Cygni 1 is that amber-colored or gold-colored star that you see in the picture, and Beta 2 Cygni is the blue star in the picture. The colors of stars tell you a lot about the star itself. That blue star, we know, is much hotter than the yellow star because the main color that we're seeing from it is blue. That indicates it's at a temperature of about 10,000 Kelvin, whereas the yellow star indicates a temperature more around about 6,000 degrees Kelvin. So actually, that even though the blue star looks a little bit smaller in this case, it's actually quite a bit hotter. Some other facts about these things is the amber star. The first one is a K3 giant. I actually said that wrong. It has a temperature of 4,400 degrees Kelvin, and its luminosity is about 950 times our sun's. It's got a radius that's about 50 times the size of our star, and the other star has a mass of about 5 times solar. It is at 11,000 degrees Kelvin, and its luminosity is 100 times our star. These stars are about 430 light years, so they're in our neighborhood pretty much, fairly close to us really, and fairly bright, because not only are they bright in an absolute sense, but because they're fairly close to us. So this is probably one of the most popular binary systems in the sky. Always like to put my telescope on and look at it because it's just such a nice, pretty, colorful object. Some people see different colors when everybody's eye is just a little bit different. And depending on your age, your eye responds to low levels of light a little bit differently. So sometimes people will see that blue star as being green, and there'll be various descriptions of the color of the other one, anywhere from gold to amber to other definitions, yellow, that sort of thing, that people see. And so it's always interesting to just put the telescope on these stars and let people tell you what colors they see and what they say.
All right. So those were several objects that saw in the summer triangle. We're going to actually move on. I'm going to go back over here to Stellarium, and we're going to move over to another part of the sky that's marked by another big shape. So let me turn back on our asterism, and let me see if I can get rid of that echo. All right. So not too far away from where you see the triangle in the sky, you can also see a big square right over here. Okay, let's zoom in on that area. There's the big square right there. This is actually the Great Square of Pegasus. Pegasus is a character in Greek and Roman mythology that looks like a flying horse. So the square right there is the body of the horse. The front legs go off in this direction. The head is up here. That star Enif marks his nose. Somewhere back here, you're supposed to get some wings. And logically, this line of stars right here would make the back legs of the horse, but actually that's another constellation altogether. That, I'll turn the constellation art back on. That's actually the owner of Pegasus. Her name is Andromeda. She's the princess of the night sky. And her mom is right next to her in the sky. And if Andromeda's a princess, you know her mom's got to be a queen. So this queen's name is Cassiopeia. So the next object that we're going to look at, I believe, is actually in the constellation of Cassiopeia. It's easiest to find Cassiopeia by looking for an asterism of an M or a W up there in the night sky. Okay, depends on what time of year you're looking at it. It's either going to be an M or a W. And then we're going to go, after we see this object in Cassiopeia, we're going to move back over to Andromeda. And it looks like, well, let me actually zoom in on it over here first of all. This one is going to be called M103. And it looks, I think it's another kind of star cluster. Let's see what Jim thinks.
Yeah, so Messier 103 is also known as NGC 581, and it is what's known as an open cluster. Now, what open clusters are is when a cloud of gas and dust collapses and starts forming stars. All those stars are all fairly close together. And as the stars start to form, what they do is the pressure from the light and all the radiation that's coming off from the stars blows away all the gas and dust away from them. What happens is the stars form, they ignite, cause that radiation to blow everything basically away from them, and then what's left is the stars and the planets and a cluster of stars. But generally speaking, in almost all cases, the stars are not close enough together like in a globular cluster to remain as a group. And so what they do is they start to disperse. And so you see a lot of these groupings of stars that get fairly dispersed. And so a group like this, which is all still fairly close together, it's a fairly tight grouping, it probably indicates it's somewhat younger than some other open clusters that are really well dispersed and hardly even look like a grouping of stars, but we know they are from spectroscopy. And so this is a very nice grouping of stars. It's about 7.2 thousand light years away. It is made up of about, let me see if I can find it on here. Usually they'll say in the descriptions here how many stars are in the thing. And let's see, its estimated age is about 25 million years. It's got a true diameter of about 15 light years, so that's pretty close together. And it is actually, interestingly, it was historically considered an accidental grouping of physically unrelated stars, but we know that it's actually a physical cluster because all of the stars have common proper motion, which just means as we observe it over time, they're all moving across the sky in the same direction. If it was a random grouping of stars, they'd all be moving in a little bit different directions, but these guys are moving together as a group. And they've proven that there's as many as 172 stars in this group. Now, compared to other groupings of other open clusters, this is actually considered to be a somewhat loose and is described as a poor cluster. But I think because it's fairly close to us and it's fairly colorful, it looks pretty nice to me, and I think it's a very nice group to look at. The interesting thing about this grouping, especially being in Cassiopeia and all, is you can pretty much see it at any time of the year because it's what's called circumpolar, which means that it never sets. So at our latitude, when you look up at the sky at night, you can always see Cassiopeia. You can always see Messier 103. Constellation, and then M103 is fairly easy to find in it.
All right. So I zoomed back out on Stellarium. So just to explain a little bit more, the star in the end of the handle of the Little Dipper right here is called the North Star. The official name for that star is Polaris. If we zoom in on it, I think it'll get identified. And from our latitude, any constellation that moves between the North Star and the horizon is actually going to be in the sky all night long and all year long. So that's what Jim was talking about with Cassiopeia. It's always up in our sky from where we live here in Albuquerque, because we're 32 degrees north. And if you measure the distance, the angle between the horizon and the North Star, you'd see it's 32 degrees above the horizon. All right, so let's go on to what I believe is our last object. And let me zoom back out and unselect that. And let's see what's the last object on our list here. The only one we haven't looked at is M32. And before I zoom in on it, let me point out to you that if you can see the Milky Way up in the night sky, you can make out, well, an object that's associated with the object that we're going to look at. And if we zoom in on it, you can see there's a lot going on there. So, and I believe Jim has a picture of just this area of the sky right here, and he's going to tell us what all this stuff is going on all around here right now.
I sure will. So I sure will. So I picked M32 to look at instead of M31, which is the big galaxy that it is a satellite galaxy of. So M32 orbits around the galaxy known as Andromeda. It's known as M31. And Jim, I'm going to go ahead and shift pictures between from this one that I have of M32. I'm going to take that one down. I'm going to bring up a picture one with M32 next to it. So hold on just a second, and let's show them this picture, because it'll give them a much better idea of where M32 is in relationship to M31. So is that up now? Tell me when okay, so then everybody can see M31 is the big galaxy there. So it's the closest large galaxy to the Milky Way. It's actually a bit bigger than the Milky Way. And M32 is that bright object that is just to the left of center. So remember that picture I just had up, just showing M32. The reason why I had that on my list for tonight is I thought I was going to be taking some pictures tonight, and my camera setup wouldn't be able to show you much of M31, but it would allow you to frame up and look at M32 real nicely. So I selected to do that. Now you may also notice, if you're paying attention, there's another galaxy in the picture. That galaxy is known as M110 or NGC, I believe it's 206, if I have it right, excuse me, 205, which is another satellite galaxy of the Andromeda Galaxy. Now, the other thing that you may notice is with Andromeda, it's got all those nice arms on it. It's known as a spiral galaxy, and it's basically a big disk. It's big, it's long, but it's thin. It's probably only about 1,000 years, 1,000 light years thick, but it's about 120, 130 million light years across. So it's much, much longer and wider than it is deep. The same thing with the Milky Way galaxy. Our galaxy's disk is only about 1,000 light years high. But you notice with M32 is it wasn't anything like that. It's not a spiral galaxy. It's known as an elliptical galaxy. In fact, it was the first galaxy that was identified as being an elliptical galaxy. It was basically a spherical galaxy. It has no arms and it just has a core and it's basically spherical in shape. So think about those globular clusters. Elliptical galaxy is just a much, much bigger globular cluster in a lot of ways. Other interesting facts about this guy, as I said, the Andromeda galaxy is about 2.5 million light years away from us. M31 has a diameter of about 6,500 light years, so it's much, much smaller than the Andromeda galaxy. And it has about 3 billion solar masses. Its total mass is about 3 billion solar masses. So it's typical of a dwarf elliptical galaxy. Fairly nice to look at, pretty easy to see in a telescope. Now the interesting thing about the Andromeda galaxy, stick around for long enough, in about 4 billion years or so, it is going to collide with the Milky Way galaxy. Now, it's moving toward us at a high rate of speed, and it'll cover that 2 million or so light years between us in about another 4 billion years. So you can do the math to figure out the actual speed. Now, the interesting thing when galaxies collide is the stars in the galaxies don't actually hit each other because there's still lots and lots of room between the stars and galaxies. So the galaxies will move basically through each other. They'll eventually they'll go past each other, and then they'll turn around and they'll come back, and eventually the Andromeda and the Milky Way galaxies will form an elliptical galaxy. And some people call that Milk-Omeda. So Milky Way with Andromeda on the end, Milk-Omeda. Okay, now that's going to take a long time for that to happen. But so what that means, though, is that elliptical galaxies, at least the big ones, tend to be older galaxies. They tend to have a lot of red stars in them because as stars age, they tend to get red. And so what happens is that you see a lot of these really big elliptical galaxies that are very reddish. They don't have a lot of stars forming anymore, and they sort of settle down into old age. And so that's the long-range history of what's going to happen for Andromeda and the Milky Way galaxies together.
Only a few billion years from now, so we got quite a long time to wait. This galaxy, if I'm mistaken, is the closest galaxy to the Milky Way, and it's also the only one that you can see up in the night sky with just your eyes without a telescope. Is that correct?
Well, it is the closest large galaxy. There are lots of galaxies that are satellite galaxies of the Milky Way. For instance, if you go to the southern hemisphere, you can see the large and the small Magellanic Clouds. Those are both dwarf galaxies that are orbiting the Milky Way. Galaxy of the Milky Way galaxy, you would see these two dwarf galaxies, the Magellanic Clouds, very much like you can see M110 and M32 here. We have 30 or 40 galaxies, dwarf galaxies have now been discovered that are satellites of the Milky Way. There are lots more of them of Andromeda as well. We just can't see them very well in this picture.
All right. Well, this was awesome, Jim. Thank you so much for collecting these pictures for us and for giving us this tour of the some deep space objects, and for staying out there in the cold and the wind in your driveway, especially. And we probably need to wrap up here in just a moment, so we'll let you go inside and warm up. Is there anything that you want to say before we wrap it up here?
No, except to say that what I was trying to do tonight was take pictures with an 8-inch Schmidt-Cassegrain telescope. I've got a camera on it. It's mounted on an elliptical mount, which tracks the sky very accurately. And if it wasn't for a bit of Wi-Fi problems tonight, we would have seen some actual pictures. So maybe we'll get a chance to do that some other time. Certainly, this setup is what I like to bring in the future to public star parties and show people pictures of what it is you're seeing in the sky. It's a little bit nicer than looking through an eyepiece because the camera gives you a much wider integration time, longer integration time, so you can see these objects much clearer with the camera than with your naked eye. So that's it for tonight, I think, Jim.
All right. Well, thanks very much again, Jim Fordyce. And you want to mention the website address again?
Yeah, so we're the Albuquerque Astronomical Society. It's TAAS.org, O-R-G.
Fordyce. And we'll let him get back to planning the Alcon Astronomical League conference now, too. All right. Thanks very much, Jim.
Good night, Jim.
All right. So we'll go ahead and wrap it up at this point. This was somewhat of an experiment tonight, along with everything else. We were actually using all free software, and it's the second time I've actually used this software online. So we had some audio issues, and I don't know why people's cameras kept resizing, but these are things that we can look into and improve in the future. So hopefully we'll be able to bring you more of these live broadcasts like this in the future, show you some things in the real night sky, and show you where you can find them like we did through Stellarium. Looks like people are still asking some questions on chat, and Jeff is still there, so we will let the broadcast actually continue for just a little bit, but I'm going to wrap it up here from here at the museum, and I'd like to thank everybody for joining us tonight. And again, if you want to go and see some of the other videos that have been prepared for Cosmic Carnival. I'm not sure if the web address ever got into the chat, so I'm just going to tell you what the web address is. It's www.cabq.gov/cosmic. COSMIC. It's actually a website that's sponsored by the city of Albuquerque. So you can actually head over there and learn a lot more about astronomy and about the night sky. And I think I'll wrap it up now. But thank you all very much for joining us tonight. And I think, and hopefully we'll be able to start having live events sometime in the next year. But for right now, we hope you all enjoy the virtual events on the Cosmic Carnival page, and have a good evening. And hopefully you can go out and look and find some of these objects in the night sky for yourself. Good night.